And I'm an algebra and pre-calculus teacher in Portsmouth, Virginia. I'm currently teaching at Churchland High School. Mr. Hale and I actually went to Norfolk State University together, got our degrees in math, and became teachers. So today we decided to team up and teach you guys about graphing and solving inequalities. So by now, you guys should have some idea of a background of solving equations. Well, for solving inequalities, it's very similar except for very few small exceptions. So let's begin with a review of the symbols that you're going to see now. As written off here on the left-hand side, you see that less than, greater than, less than or equal to, and greater than or equal to. Just as you're reading literature, we read math problems from left to right. Now we'll take a look at some examples. Reading from left to right, as I just mentioned, we'll read example 1 as n is less than 1. We can graph this statement. Well, first we want to find 1 on our number line. We're going to have an open circle. We have an open circle because our symbol is less than, which means that n cannot equal 1. It has to be less than 1. And then we want to shade values that are less than 1. And you can think of your symbol, your less than symbol, as an arrow. It's telling us to go to the left. This is the graph of a one variable inequality. So as we note here, is that when we have the symbol less than, we have to have an open circle because n cannot equal 1, it's just values less than 1. In other words, this is known as exclusive. Example 2, a is greater than or equal to 0. We'll locate 0 on our number line. This time, since a can equal 0, we're going to give it a solid circle. In our notes, a solid circle means inclusive. And once again, we're going to look at our symbol as an arrow, and it's pointing to the right, so we're going to shade values greater than 0. Just as the statement reads, a is greater than or equal to 0. In our final example, let's read it forward and backwards, and you'll see why. Negative 2 is greater than or equal to x. Well, this statement read backwards says x is less than or equal to negative 2. So again, we'll find negative 2 on our number line. Because that equal symbol is also there, we're going to give it a shaded or a solid circle. Excuse my word. And then again, we're going to look at our symbol as an arrow, and we're going to shade to the left because behind negative 2 are values that are less than or equal to negative 2. So 3 is as the product of 4 and a number minus 3 is less than 3. So first we're going to solve for our variable using our steps from solving equations. We always undo addition and subtraction first. So the opposite of minus 3 would be plus 3. And whatever you do to one side, always and forever, you do it to both sides. Well, now we're going to simplify. Negative 3 and positive 3 will cancel one another. 4x is less than 6. Our final step is to divide both sides by 4. And we know to divide because it says 4 times the number x. Well, the opposite of 4 times x would be 4 divided by 4. 4 divided by 4 reduces to positive 1. X is less than 3 halves. We're just going to reduce the fraction. Now, again with our number line, 3 halves can be found between positive 1 and positive 2. So we'll just make an arbitrary circle for now. Open circle because x is strictly less than 3 halves. Again, look at the symbol as an arrow. It will shade to the left. So now that is a review on solving inequalities. Mr. Hill is going to take over from here to wrap up solving inequalities, and he's going to introduce to you the special rules that make solving inequalities different from solving